So I'll talk about solving the speech recognition problem in wearables. Most of you have experience with speech recognition. You know, in the old days, you have command control, and in iPhone, you have Siri, and Google phone, you have Google Now, and also now Alexa Echo. I think most of people have used it before and pretty familiar with it. So I'm going to talk about how we're going to integrate the speech recognition in the VR and AR space, and how to make it work in anywhere, everywhere, in all the cases. So here's the evolution of a human-machine interface. In the old days, you know, the keyboard, of course, right? And then when the GUI come along, there's a mouse. And in 2007, there's iPhone multi-touch. And then in 2011, there's Siri came out, right? Then you can talk to it. And then 2.5 years ago, 3 years ago almost, Amazon Echo. So you can talk to it at home, just like Siri, but you don't have to have a display, and you just it's a full audio feedback and input and output. All of them are audio. So far we still, you know, all the speech recognition, it only works in the quiet environment at your home when there's no noise. But once you bring it in the wearable, you can go anywhere. You'll be outdoor. You're subject to the severe noisy environment. And most of us has experience with it that, you know, the speech recognition wouldn't work. It fails. So in the future, the speech recognition will be the next interface, the next touch, because it's the easiest, the most natural way of input method. So the consumer benefits of the voice UI, we call it voice UI, it's pretty fast. We talk pretty fast. We talk 150 words a minute, versus you can only type 40 minutes. And when you're typing, you basically you tie down to your screen and to your display, or in the computer time, you have to sit in front of the desktop. And when you can talk to it, then you're hands-free. You get instant response, and your phone can be in your pocket, and you can use your wearable. That's the most natural way of talking to it. And when we all have experience with Siri now, it's conversational. So it means that it not only recognizes the words, it's contextual. You can, there's natural language processing behind it. So it will understand what you're talking, and even you got it wrong, it can correct it to some degree. So that's very helpful. That's a big step forward in the natural voice interface, voice UI. So people loves it, right, when it works. But when it's not working, when it fails, you're frustrated. You don't like that. So here's a graph that plot by Google. The data is supplied by the Google. And when time goes by, when it's 1970 to 2016, the vocabulary of the speech recognition can recognize increase dramatically, you know, to 10 million. And the recognition rate can go, you know, from 70% in the just 6-7 years ago to over 90%. Now it's mostly likely to be 95-96%. But are we there yet? Not yet, not quite. It only works in the quiet environment. It doesn't work in noisy environment. So the next step we'll go to the noisy environment. Especially for AR, you have to go everywhere, right? You have to wear it. You're subject to, you cannot control the environment, the noise level and the type of noise and how many noise there's everywhere. So the 10% failure rate is still kind of high. You don't want to have every 10 sentences you say as one got it wrong. That won't work. So the best scenario is that if we can get like 99% of accuracy, at least 95 plus accuracy. So, but the problem is not only in the far field, like an Echo, Amazon Echo, you talk in a distance, right? Like you can talk to it 5 meters away. But once you are in noisy environment, you cannot do that actually. So let's make it work in the near distance. I mean, when you wear it, like glass or something, the mic is pretty close to your mouth, so it's a near field. And once you make it work, and then you're more confident, you can go far field. So we're relevant to AR and VR. It's in most of the case is near field. So there's a criteria when people to have confidence in the voice recognition is that when you have 95% of accuracy, people still kind of, trust it halfway. I mean, it's not 100%. It doesn't recognize you. Sometimes it fails. For adults, we are used to like 99% of accuracy when you in human conversation. We're kind of hesitate to use it, even if it's in 95%. But for kids, for smaller kids, it's much more likely they will use this speech recognition, even if it's 95%. They're used to it. And then, of course, when time goes by, it will go from 95% to 99%. 99% is really crucial, a game changer. People will fully trust the 99% system. And of course, you don't want to wait for a few seconds to get a response back, right? When you talk to somebody, you expect them to recognize it right away. You don't want an online system. Sometimes, you got a bad cellular connection, Wi-Fi connection, you don't get it back on time. Sometimes it's slow, it's kind of annoying. So accuracy and latency is the key when you design a system. The current ASR system, when it fails, why it fails, most of the time it's because of noise. Users are frustrated because it fails too often, especially in a noisy environment, in outdoor, when you're driving, it won't work. Most of the time it will fail. That's not good. But in quiet environment, we are kind of used to it now. ASR together with natural language processing, NLP, make the voice conversation very natural, like Siri or Cortana, Google Now, Alexa. We all have experience with that. So voice is taking over home, but not mobile and wearables. Especially in wearables, I haven't seen many voice recognition system integrated in wearable. Maybe because there's nobody take the lead to jump into that. And a big problem also is the noise. People think of noise as a roadblock, and it's hard to deal with. So people hesitate to go into that field. So in the real world, it's always noisy. You can't have a quiet environment in a real world when you go out. So the noise management is only a real barrier left in the voice interface. So there's noise measurement, voice pickup, noise cancellation, and then after that followed by speech recognition. And after that is followed by the natural language processing. It dissects your language, it analyzes your verb and the subject, objective. But then it goes into the AI, artificial intelligence. So the noise management is like the gatekeeper. If it doesn't work, all the other thing fails. You have the garbage in, garbage out. So how to make it work in noisy environment, that's really a key for a voice interface, or voice user interface. So let me talk about why most of the voice interface fails, why the noise management does not work. Because so far, most of the multi-mic or single mic noise cancellation software or algorithm, it's designed for voice communication, for phone calls. For phone calls, human can recognize even the voice distorted a little. You still can recognize it, but the machine cannot, because the machine is trained on clean, undistorted signal. It's not trained on the distorted signal. So that's why most of the technology out there, it fails. It doesn't work. In fact, there is no standard in the speech recognition performance to qualify the noise cancellation technology for speech recognition. There's standards like a 3Quest or something that's everybody use for voice quality, making phone call. But there's no standard exist so far in voice recognition to test or quantify the noise cancellation performance built for speech recognition. So the reason is that most of the time, most of the software analyze the noise, analyze the voice in an atomic way. They try to model the noise, they try to model the voice, and they try to put them together. It's a brute force method approach. It actually distorts the speech. When the speech is distorted, when you feed into an ASR, it doesn't work. So Kopin developed a new technology, a completely new technology. We call it a whisper. It's a chip technology. We're taking a totally different approach. We use a holistic approach. That means you're not gonna analyze or model the noise or voice separately in piece. You're gonna model the whole thing, because the environment and everything is it cannot be divided into, it's interacted to each other. So the system, our chip sample at the 16K per second of sample rate, of course, it will dynamically analyze the voice and the noise environment, acoustic environment basically, in real time, adaptively. We call this technology voice extraction filter, VEF. The result is that we can clean up the voice without a distorted voice. That's very different from the conventional technology for voice phone call. We have over 30 patents on that technology. As I said, the other systems use atomic approach. That means they analyze, like speech and voice in time domain, in frequency domain, in spatial domain, how many noise source there is, and that. But it's very complex. It's very, you can't exhaust, all kind of noise type of noise model or speech. You can't analyze them by separate them, right? You have to analyze them as a whole. We build a model for the whole thing: noise, voice, and environment. So we tested our system. Our system has been proved. We are deployed in the real environment in the market for industrial it outperforms anything out there in the market. We tested in the real environment as between like 75 to 95, sometimes go to 105 dB, dBA. The ASR performance constantly outperform anything we saw in the market 2 to 4 times. And the technology is good for near talk, mid-range talk, and far talk. And it can be programmed, adjusted for that. Even in very, very noisy environment, we still can get your voice recognized. Not only in command and control, and also in like Siri, like dictation, like when you say a whole sentence, it can recognize. I'll show a demo later. I'll show you the data later. But of course, it also provide the phone call quality voice, because it will enable not only your speech recognition, also enable your voice communication, right? And the technology itself is in a form of an IC chip. It's 4x4, a small size. And it's speech engine independent. So we are not optimized or trained for particular speech engine like Nuance engine or Google engine or Apple engine. It's independent of the speech engine. It works for every engine. It's just like a module you plug into between your speech engine, your microphone. It will work like magic. It's OS independent. It doesn't have anything to do with the OS, whether it's iOS or Android. Also processor independent, because it's in a chip. It doesn't have anything to do with your AP processor. You can choose any of one of them. So today we have the version 1 of the chip. It's ideal. It's specially designed for smart glass, wearable watch, headset, and other wearables. The version 2 will come out soon. It also works for the far field, IoT or something. Far field, so something like Amazon Echo speaker. So the voice is a new touch. Think about voice as the next major input method, like multi-touch.
Read my lips.
So here's a demo. Just Yeah, this is what we recorded in 2016 CES. It's 1.5 years ago, and it's used the Google engine. This is a Kopin glass. It's like an AR glass. It's got a little display on the corner, and there's also two microphones on the frame, and there's whisper chip in there. And you can do voice processing after microphone pickup, and then send it over directly to Google Now. This is recognized. See the long sentence is recognized by Google Now, and the command control is recognized by the local engine on the PC. This is hooked up to a tablet, but also you can install the software in cell phone or something. The command control is recognized locally, and the dictation or the search is recognized online, connected. So you see, you can't even tell what he's talking. You can only hear his lip moving, but the machine recognizes it. That's how our engine, how our technology performs in the real world. We show you this this demo. And here's some data. We got this this data we have 2 years ago. We have some data. This is a year from, this data mainly from a half year ago. We compare several devices. You see that there are six devices. The blue line on the top is the glass you saw on the demo, on the recording. And the red line is another Bluetooth headset prototype we have. And the next one is a leading Bluetooth headset manufacturer. It's a very popular one. It's got a 4-mic in there. And see, the 4-mic one doesn't perform as good as our 2-mic one. And our 2-mic one is not optimized yet. It's just a prototype. And we outperform the 4-mic. And all the other one are, including a glass. I can't disclose the name, but it's a brand name. It's a very big brand name. And also the hearables and earbuds from the leading manufacturer without our technology. So the voice communication is okay. You can make phone call on those devices, but you can't do speech recognition. Especially Bluetooth headset is notorious for bad speech recognition. It doesn't work with Siri and Google Now. The reason is that it distorts the speech. It distorts speech severely. The speech engine is not prepared for. So these are the conditions we tested in the standard ANSI lab. That lab has some reflection. If you're acoustic in the field, you probably know this. It's a standard lab, test lab. It's got an 8-speaker, 4-speaker, or 8-speaker with a mannequin with the heads. All of them is using speech, use Google Now. Okay. Okay. So I'm going to talk a little more about the AR and VR, how are we going to implement this. So for AR and VR, to use a voice UI, our Whisper 1 chip is targeted to that. AR glass is a near eye, it's a near eye. And it can do search and answer like Google's Google Siri, an intelligent assistant, right? It can also do voice communication. For VR glass, it's also near eye, right? Its most useful one is command control. You want to use voice to replace your remote or your joystick or something. A lot of command can be done by voice. Of course, you can use gesture, but a gesture you have to wave your hand around. It's energy consuming, right? If Whisper 2 is working far field, it will come out. But so voice UI is a perfect input method for AR and VR. And Whisper chip is a perfect solution for voice user interface. Whisper 1 is specifically designed for this type of application. So there are many design issues. People think the speech recognition is simple, but it's not. Let's look at a speech engine. 20 years ago, you only talk about speech recognition, you only think about command control. You talk some command, it recognizes. And then Siri come out, it's a question and answer, it's a search and answer kind of system. Or is it a conversational? So VR, most of the command control is probably good enough. Replace hand control, right? For AR, you need a search. You want to search a restaurant, a map or something. Question and answer kind of. A real conversational voice UI is they remember context. They remember the last sentence, last sentence you said. It's more natural, but it's not. We are not there yet. Do you have to talk loud in noisy environment or not? Okay, this is you saw the demo. We don't have to talk really not loud. And do you need a wake up word? A wake up word is very tiring. If you have to every command you say, you have to say Alexa. It's very tiring. Soon you will be tired. So you want it always on for VR or something. It's got a battery. And do you want another problem is crosstalk. Do you want somebody else next to you get control of your machine? You don't, right? You don't want other people to talk. So that our technology can cancel out other people's voice their command cannot trigger you. So without an effective solution to noise, your choice in design is very limited. You cannot do that. Without a seamless, reliable UI, your user experience is very bad. It's poor. So this is a detailed of, there's 2 mic or 1 mic, a 4 mic configuration, a different way. Is that a near eye, near, AR+VR is near eye, but like headset is near ear. A near mouse is like a boom. If it's far talk, if it's outdoor, then you have to consider the noise, wind noise issue. Indoor VR, you probably don't. So Whisper provides optimized design solution for your specific product ID. You can differentiate the product ID, yeah, okay. So the final words here. The most important for a great voice UI for AR and VR is voice user experience. Whatever the interface is, the user experience is the most important. Reliability, of course, you want 99%. But if you can't get in 95%, maybe you use the command control, it can be 99%. Of course, the response is instantaneous. You want it very reliable, instantaneous. The interface should be simple. It's not like you don't have to remember the menu or something. You just talk it to it naturally. Wake up word every time. Like I said already, wake up word is tiring, no touch. I already said this kind of thing. So Whisper will remove the biggest roadblock in your voice UI design, which is noise. Once you remove noise, there are many things you think you cannot do, it can be done. For example, the conversational, if without noise cancellation, there's noise, so you always have to use a wake up word. But without chip in there, you may not have to use wake up word. It's natural. So there's many aspects when you design an interface, and especially voice UI, be creative. Don't just take whatever Google, Apple, or Amazon for granted. Your system may be different. You can add our technology and solve your specific problem, make it more user-friendly, better user experience than what you have in a cell phone. Okay, thank you. If you have questions.